G'day there, you're watching the Aussie BIM Guru, and today you've reached part 8 of my feasibility series in Dynamo and Revit. So we've originally looked at setting up a feasibility study in Revit in 5 parts, and then we've moved into Dynamo to do some analysis of our site and our options. So we've looked at shadow diagrams and how to set those up really quickly, and we've just looked at how to set up basically an array of sensors on the face of our building in order to undertake detailed studies that these sensors can generate, such as view analysis and sun hour analysis. And we're going to finish up by looking at how these can be used in Power BI, as well as our Revit feasibility study as well. So you may recall, if you have seen the last part, which I recommend you do, that we've basically set up a network of sensors on an array across the face of each side of our building option. And we're basically going to use these to generate test points. And we've tried to achieve a fairly uniform distribution so that we don't have too much bias on certain portions of our building, so that if we look at these en masse, we'll get a very rough estimate of the percentage that we'll probably achieve in a view analysis or a sun hour analysis if we were to only measure detailed points of our building, such as living rooms. So in this case, you can see that we're going to eventually use it for sun vectors, but today we're going to use it for view analysis instead, because it's a little bit more simple, and sun hours is going to be a bit more complicated. So views can be positive. Sometimes we want to see things in our buildings, and we want to be able to justify to our clients how much of their apartment yield can see a certain view, for example, because this gives them the means to justify to people that they can basically charge more money. So it's good to tell our client with confidence what they can see from their building and their apartments. And they can also be negative as well. So sometimes we're not trying to see certain things, so we internally might try and design to avoid certain views, or our client mates might say, none of my apartments can see this construction site. It's against the rule of the design. So it might be something that we have to achieve. And also negative views are often related to bad acoustics. So usually you won't want glazing facing very loud sources of noise, because the only way to solve this is to use thickened glass or toughened glass, things that can absorb more sound, which cost more money. So where possible, it's good to avoid these sort of scenarios. But today's example is the Sydney Tower, which is right in the middle of the city, and it's a nice thing to be able to see because it's a landmark that really defines the Sydney skyline. So we're going to test how many of our apartments and our commercial offices can really see this element based on one of our design options. So we're going to try and prove the merit of the design. So we're more or less just going to take a study a little bit like this. So we're going to take a point on the landmark, and we're going to use our sensors to receive a line and see if it intersects with our site. Basically, is the site in the way of the view? And we'll use Dynamo. And we're not going to use any custom nodes today. I think we're using all out-of-the-box nodes in this script. And we're going to be using version 2.0.3 of Dynamo, but I think you may need to be in version 2 at the very least in order to have reached this point, especially the last part of my series, which I think needed version 2 at the very least, but I recommend you use 2.0.3 if possible. Okay, so without further ado, we're just going to jump straight back to our feasibility study and undertake our view analysis. So I've made a little bit of work on my site since the last part. So because we're going to be dealing with this element here, I've actually modeled more of my site in Revit. So you can see I've modeled this entire zone as extrusions, as a generic model in place. And the reason I've done this is because it's much easier for Dynamo to process geometry that's native to Revit, and probably more simple than a CAD file, because CAD doesn't always have closed surfaces. There's a lot of issues with how Dynamo interprets it, so I just took a little bit of time to model my site. This probably took me about 10 minutes to do, so I think it's worth the effort. The good thing about this as well is it looks a lot better when you do a 3D shot in Revit, because you can actually interact with these elements as native geometry instead. What I've also done is I've set up another object style under generic models for landmarks. So if I go to generic models, I've basically just set up an additional object style called Feasibility Landmark, and I'm just making its outline blue. And I've made sure that it's a separate family, and that's so I can exclude this from my view analysis, because I obviously don't want to clash my view with the element we're trying to view, because that would be misleading. We really want to ignore this element in our view study, but we want to go from a point upon the surface of this element. So what we're going to do is just turn on our option that we're testing, which is option 1B, our commercial residential stack. So the lower portion of our building is commercial and the upper portion is residential. In the last part, we actually set up our sensors already using Dynamo. So these are already in place, ready to go. So if I select one of these, you'll also recall that we told them which option they belong to in one of their parameters, and we also told them which face they belong to as well. So south podium, south tower, west tower, west podium, etc. So we're going to try and use a filter to be able to limit how many things we test in this particular study. Anyway, pretty much from here, we need to make a few changes to our sensor family first. So if I just go edit family, we need to add a parameter that basically tells it whether it is receiving a view or not. So in the type properties of the sensor, we're going to make a new parameter, and we're going to use a shared parameter. And I've set up a parameter already in my shared parameter file called abg data view1, and it's a Boolean parameter, so a yes/no parameter. So if I just go to data and I check the properties, you'll see that it's a yes/no parameter. So we're going to add that to our sensor family as an instance parameter. And by default, we want it to be off, because we don't want our views to say they have a view from the start. We want Dynamo to tell it whether it has a view or not. So we're going to load that back into our project and just overwrite. And now we need to set up two filters in order to represent the ones that can see the element and the ones that can't. So I'm going to use red to represent the ones that can't and green to represent the ones that can. We'll get into Dynamo quite soon. One thing I like to do with these math studies as well sometimes is actually turn off mass floors and override my mass just to be one color when we're not trying to focus on program. Makes it a lot easier to just focus on the sensors instead. And there you go. See, that's much easier to focus on our sensors now. So I'm going to set up two filters under filters. So one of them will just be called detectors view yes. So this will mean that our detectors are receiving. But you'll notice if we go to generic models, we can't actually access our parameter that we've added to our family. That's because we also need to add it in the project as well. So under manage project parameters, we'll just do the same process. We'll add a shared parameter and we'll find that view parameter. We'll add it under analysis results and we'll apply this to generic models. Okay. So now when we go back to our filter, we should be able to access that parameter. Great. So we're going to say for this one, parameter equals yes. And then we're going to duplicate this filter and make one for no, or false or off, depending how you call your booleans. Okay, and in this particular view, we'll just add those two filters. And when it's yes, we'll just say that its line is green and its fill pattern is also green. And we'll just make them the same color so that they get overridden to just a flat primary color. We'll just make these red. So there's just a little bit of templating in order to represent our study. So we should expect that by default, all our sensors should be off. So you'll see that they've gone to red because their view is set to no. But if I turn it on, obviously it goes green and we can see that we can actually see the study from there. If you want, you can also make just them, maybe you can make them halftone and gray, and that might make it a little bit more obvious when they're off versus when they're on. That can make quite a high contrast. But it does sort of wash out the building a little bit. But the good thing about that is that it's very obvious when your view is on versus when it's off. So maybe for now we'll do that. What we're going to do too is place a sensor on our landmark as well. So we're going to go to architecture. Actually, we'll just be able to do a create similar on our sensor. So we're going to use the same family. And we're going to place on face. And we're just going to place it somewhere on the face of what we're looking at. And we're just going to duplicate and call this a different type. So let's just call this viewpoint, because we don't want to use this when we test our viewpoint, and you can make it a bit bigger if you want. Cool, so now we can see our viewpoint. And if you want it to be really obvious, you can just turn it on to be filtered by that particular view study. Okay, so we're pretty much ready to go at this point. So what we're going to do is actually start working in Dynamo on our script. So the first thing we're going to need to do in Dynamo is we'll go to manual mode and we'll set our geometry scaling to extra large because we're working with our site, which is quite big. I'm just going to save my script. So we'll just call this demo version. And we're going to get our model geometry for our site, but I think we'll do that first. So we'll get our geometry for clashing. And we'll just call this model elements. So select model elements is what we need. And I'm just going to isolate the things that we want to select, because it can be quite hard to select massing at the same time as other elements. So I'm just going to select massing and my site. So these three elements, because essentially this is what we want to clash our sensors against. You recall that we offset our sensors slightly outside our building. That's so that if you have a sensor on the back side of the building, when it checks a view, it clashes with the building, so you can deal with self-intersecting views. Otherwise, it would just go straight through the building and would think that it can see the building, which is incorrect. So now that we've got these, we can just go back to Dynamo, move this off to the side, and we can do a select model elements and just do a marquee. And we can see we've got three elements selected now. And what we can do on this side is we can reset temporary height isolate so we can see everything again. But from here we can probably just work in Dynamo, actually. So I'm just going to save that, and I'm just going to get the element geometry of my site. And depending on your site, this may take longer, but I know that this site doesn't take too long to generate in Dynamo. So basically it will generate a Dynamo version of the site. So I can see here, this is my site geometry. And it comes out as detailed as it is in Revit. But if that was a CAD file, it would probably struggle. So what we should have in here is a whole bunch of solids. So basically every extrusion's been turned into a solid. What we want to do is just flatten that list, because we want to turn this into one element to clash. So we're going to flatten that list, and then we're going to do a solid by union. So we're going to do solid union by union, and then we're going to just turn that into one big solid. And the great thing about this tool is it doesn't have to be all interconnected. These elements can have space between them, and Dynamo still treats them as one solid. And what I'd recommend doing is just turning off the preview of your element geometry and your flatten node. I don't believe it matters if you turn off preview for select model elements. We'll just call this geometry to clash. If it'll let us. Seems to be struggling. There we go. Because we're going to make this an input in Dynamo Player. Okay, so we've got our site at this point. But what we're going to do now is go back and actually get all our sensors. So we need to get all the family types in our project. And you recall that we made a different type for our detector on our landmark. And that's because we want to just pick the detectors that relate to our study. So we're going to take a family instance by family type node to get all the instances of those. We'll just double check from the browser. I think sometimes these nodes are easier to find in the browser because you can actually see all the ones that it's trying to show you. Family instance. There we go. Family instance by family type. A little bit of a hard one to find, that one. And if we run that, it should find all the detectors. And you can see we have quite a lot. We have 1561. We have more than 1,500 detectors. So it's going to take a little while to do some of these phases. What we're going to do is get a parameter, because we need to filter in some cases. We don't always want to just get all the sensors. Sometimes we might just be testing one face or one portion of the building, say the upper portion with the residential, because maybe commercial, the view doesn't matter. It usually will, but sometimes you might want to just do an isolated test. Okay, so we're just going to get a string here, and this is just going to be our parameter that we want to filter by. I'm just going to make it free text, and I'm just going to pick comment 2 as our field, which is basically what face of the building we're dealing with. And what we want to do is we want to filter basically if that string contains a particular phrase that we can give our script to filter down what we're dealing with. So we're going to use a string contains node. So we're going to say, does this contain, and we'll make a string that the user can populate. And by default, I'll just leave that blank. And I'll call that value to filter. So what are we filtering? And which parameter are we filtering as well? So we'll just check that it contains empty, because by default, every string will contain empty. We'll just go ignore case as well, just so the user doesn't have to worry about their case. And it should give us a list of booleans. In this case, we're going to get a true, but let's say we only want to look at the south side of our building. I'll just say value to filter south. And we'll get some trues, but we'll also get some falses as well. So that's why we want to add that filter. And what we want to do from there is just set up a filter by a boolean mask. I'm just going to move this off to the side. And I'm just going to move this. I'll move these elements down so that we can run our filter by Boolean mask past. So essentially this will break our list into the ones that meet the criteria and the ones that don't. What we want to do from there is get the location of those instances. So we're going to get the location of the family instance. And this will actually give us a point in Dynamo for that sensor's center point. So if I run that, you'll see that now we get points for all our sensors. So each of our sensors has a location in Dynamo now, which is really important. What we're going to do from there is actually pick our viewpoint element. So we're going to do select model element. We'll keep it simple. So I'm going to go and select my viewpoint as my viewpoint element. So we'll call that viewpoint element. And we'll come back and set this up for Dynamo Player at the end. And likewise, we want to get the location of that viewpoint as well. Okay, so what we're going to do from there is create a line by start point, end point. And the start point of each of those lines is going to be the location of the sensor to the viewpoint, because this is the line we're going to clash with our site. We're going to set our lacing to longest so that it basically creates one line for every single point to the viewpoint. If we did shortest, it would only do one line. So we want it to do every single one. So what we can do from there, I'll just run this so you can see what it looks like. This will this will help you understand what we're doing now. So we're basically drawing a line from every single one of those to our viewpoint. But obviously some of those things are going through our building, and some of those things are going through other buildings of our site as well. So this is where we need to clash this versus our site. So what we're going to do with this data is we're going to check if it intersects. And this is the node that can take a little bit of time to run. So I'll just add does intersect. And the way we want to run this node is we want to check if the line by start point endpoint clashes with the geometry of our site. I'm not going to run it just yet because I'm going to take a few more steps, just because it takes a bit longer to run this particular node, because it's handling a lot of geometry. But we're going to do a Boolean mask after that. And we're going to go back and filter our families. So we're going to say we only want the sensors that don't intersect with the site. So we're going to just mask based on the intersection. And we're going to take our out list. And our out list would basically represent all the lines that don't clash with anything. So what I'm going to do is just turn off the preview for this Boolean mask, because it will show us the ones that do and don't clash. And I'm also just going to turn off my lines by start point, end point. And what we should be left with is the ones that actually don't clash. So I'm just going to run that node. It will take a little bit of time, so I may skip forward. Otherwise, maybe I'll just sit here and make you watch and wait. But it should take about maybe 30 seconds to a minute in order to generate this result, which is why filtering down can sometimes be better, because you can do smaller studies and sort of spread apart the load that you're putting on your computer. It's up to you. Probably a good time for a drink. That's why they call me the Aussie BIM guru. Alright. If they call me that. Anytime now. Much longer and it'll get awkward. Alright. So that should have just worked. Interesting. I've taken my family instances. What I wanted to do is get my lines just to show you what's happening. So I'm going to filter my lines instead and just show you the ones that worked, because these are basically our points, but these are our lines. And there you go. So now you can see that what's happened is the ones that don't actually see the tower have been filtered out. See how it sort of goes around the building at that point? So that's how we know which sensors are actually seeing this element. So it's really cool being able to see that, I think. Really visualizes it quite well. What we're going to do is we're going to turn that off, and we're just going to freeze this node, because we only really use this just to test our script essentially. So this is all our nodes that work. So at this point we want to set parameter values. We want to tell which ones receive and which ones don't. So we're going to set parameter value by name. And we're going to set the ones that do and the ones that don't. just in case you've already run a study and you need to reset the ones that thought they saw an original study but don't see this one. Okay, so we're going to take the ones that don't and the ones that do, and I'll just make a code block. So the parameter that we're dealing with is that view parameter that I set up before. You might be using a different one, and we're just going to add a false and a true line. So we're going to be setting that parameter in both cases, but these are the ones that can't see the tower, so these ones are going to be false. These are the ones that do, so this will be true. Okay, and from there we'll set our lacing to longest just to make sure that it applies to the longest length that it can. Okay, so that should work, but what I might do is actually just set this up for Dynamo Player and run this via Dynamo Player instead. It'll take a little bit longer, so I'll probably skip ahead when I run it that way. Okay, so our first input is our family type for our detectors. So I'll right click that and set is input. Our parameter to filter is our next one. And what we're filtering as our value is our next one as well. From there, what is our site geometry to clash? What is our viewpoint element? And then also, I think actually that's it. So that's all we need in order to run this script. I probably won't actually run this out of Dynamo Player. I just might show you the interface instead, just because it's even slower to run out of Dynamo Player. Okay, so I'm just going to run my script now. And I should expect that my sensors will be told whether they can see the tower or not. And there you go. You can see that my sensors have received the data, and I can see that these particular elements can't see the tower, and which is sort of what we'd expect because of this building that's in the way. So you can sort of make sense of that result by lining yourself up with the building. But really easy, so you can imagine if you had quite a complicated site, sometimes it wouldn't be so obvious whether something can be seen. And obviously we can just rerun that really quickly if we wanted to by moving this point over here. I won't in this case just because we've already made it run. But that's pretty much how you can do viewpoint analysis. So I'll just show you the interface in Dynamo Player real quick. So if I open up Dynamo Player and I just expand my inputs, you'll see that we'll pretty much have the inputs that we specified available, so that a user can run this without going into Dynamo. Because of the speed, sometimes it is better to run it natively out of Dynamo because it's faster than Dynamo Player. And as you saw, this script can take a little while to run, depending on how many sensors you have. You can see there it's remembering the defaults that I've given it. So obviously we could filter by lots of things there. We could filter by different parameters such as comment 1. My original study, comment 1, deals with the option rather than the face. So that's how we can tell it to only deal with sensors that belong to particular design options, even though it sees all the sensors in the whole project. And from there, we can obviously pick different viewpoint elements as well, rather than moving our viewpoint around the model. But that's pretty much it. So a really helpful tool, I think, that should help you sort of justify views to your client using Dynamo. So hopefully that helps. In the next part, we're going to get a lot more detailed, and we're probably going to look at sun-hour analysis in potentially 2 parts, because it's quite a long script to build, and it's quite complicated. But it uses a very similar principle to what we've just done, but instead we're directing our sun rays out from each sensor and clashing them against our site. So a pretty exciting tutorial. I think it'll probably be well received. So we'll be looking at something like this instead. So are our sun rays coming out and hitting our site? But we're going to look at multiple hours of the day. So a bit more complicated than what we've just done. So thanks for watching today. Hopefully you got a lot out of that, and it's given you another tool that you can work with. If you're not already following and subscribing, feel free to do so. And feel free to leave any comments or feedback down below. Hopefully I'll see you in the next video, and thanks. Take care. Bye.